Now, let's solve 10b. Integration of 1 over x to the power 6 dx. First here, I will rewrite it as a negative exponent. So it will be x to the power negative 6 dx. Then, I will continue here now. The exponent here is negative 6. So I will say x to the power negative 6 plus 1 over negative 6 plus 1. So I will add 1 to the new exponents, then I will write it under the new exponent plus c. So it becomes as x to the power negative 5 over negative 5 plus c. Or you can write it as negative 1 over 5 x to the power 5 plus c. This is for b. Now, let's do it for c. For c here now, integration of x to the power negative 7 over 8 dx. Here, I will say x. Now, where's my exponent? It is negative 7 over 8. So I will take this exponent. I will add 1 to it. Then, as I told you yesterday, if I want to add any whole number to an fraction, I must keep the whole number with the same, I'll have both of them have the same denominator. So if I multiply down by 8, I must multiply up by 8. Then negative 7 plus 8 is 1 over 8 over 1 over 8 plus c. But let's simplify it now. 1 over 8, that's mean the reciprocal of 1 over 8, which is 8. And x to the power 1 over 8, I write it as the 8th root of x plus c. This will be now the integration of x to the power negative 7 over 8. It is 8, the 8th root of x plus c. Is it clear?
Yes, teacher.
Did you find that your answers for the homework correct?
Yes, teacher.
Yeah.
Okay.
Yes, teacher.
Now, let's talk about the properties of the indefinite integral. Our first properties of antiderivatives follow directly from the simple constant factor, sum, and different rules for derivative. Suppose that, let's talk about this one here. Suppose that f of x and g of x are antiderivatives of x and g of x, respectively, and that c is a constant. Then, like how we did in the derivative, we will do here for the integration. What does it mean? If you have 3 integration of 3x squared, here you can't keep the 3 since it's a constant factor, so you can move the 3 outside the integral sign. So it comes like 3 integration of x squared. I will repeat, if there's a variable x times 3 constants c, I will move the constant c out of the integral sign, then I will do integrate. So it will be 3, and then the integration of x squared is x cubic over 3 plus c. So then 3 cancel 3, so it comes like x cubic plus c. So if you have any constant, just you have to move the constant throughout the integral sign. and then you will continue the integration for the variable. The second one here, that the antiderivative of a sum is the sum of the antiderivative. That means you can, if they are two functions, they are added, you can integrate each function alone or separately. That's mean like if you have an 3 or without 3. If you have an x squared plus 3x, and I want to integrate it. Here, I can distribute the integral sign for x squared first and then for 3x. So I can distribute the integral sign for the two functions that they are added. And if they are subtracted also, an antiderivative of a difference is the difference of antiderivative. This is for the properties of the integral sign. The statements here can be summarized by the following formulas, like integration of constant times f of x. As I told you, I will keep the constant c outside the function times the integration of f of x. If I have two functions that they are added, like integration of f of x plus g of x, I'll distribute the integration sign to f of x and to g of x. And if they are subtracted, I will do the same step. I'll distribute the integral sign for f of x minus the integral sign of g of x. Let's have here some examples. Evaluate integration of 4 cosine x dx. Now, here as we see, we have a constant. Let's put the constant outside the function. So it comes like 4 integration of cosine x dx. Then I will integrate. What is the integration of cosine?
Sine.
Sine, exactly. Sine x plus c. So the integral function will be 4 sine x plus c. Let's do b now. In b here now we have integration of x plus x squared. Here as we see, we have two functions that they are added. Dx. So I will distribute the integral sign into the first function plus the second one. Okay, I will distribute the integral sign into x and x squared. Then after that now, let's find the integration. The integration of x to the power 1 is x to the power 1 plus 1 over 1 plus 1. Here we have x, so it's power, or it's raised to the power 1 plus x. Now here the power is 2, so I will add 1 under the new exponent here plus c. So it comes like x squared over 2 plus x cubic over 3 plus c. Is it clear?
Yes,
Yes,
teacher.
teacher.
Okay.
Dima? Teacher?
Yes, Shahad.
Why the integration of x is not 1?
This is derivative of x is 1.
Oh, okay.
Integration of x, here you have x raised to the power 1. Sorry. Here we have x raised to the power 1, so I will add 1 over plus 1. Let's now do this example here. The integration of 3x to the power 6 minus 2x squared plus 7x plus 1 dx. Now here, I will distribute the integral sign into 3x to the power 6 minus integration of 2x squared plus the integration of 7x plus the integration of 1 dx. Okay, so I distributed here the integral sign into the 4 functions here. Then after that, now here, after we distribute the integral sign, let's now integrate. Here now, as you see, we have a constant. So let's put the constant outside the function. So it's like outside the integral sign. 3 integration of x to the power 6 minus 2 integration of x squared plus 7 integration of x plus the integration of 1 dx. Then after that, let's integrate. Now 3 x to the power 6. Here we have the exponent 6. So it is x to the power 6 plus 1 over 6 plus 1 minus 2x. Now here the exponent is what? Is 2. So I will add 2 to the 1 over 2 plus 1 plus 7. Then now here we have x. Now it is x to the power 1. So I will add 1 over 1 plus 1. Then plus. Now what is the integration of 1?
X.
It is x. Exactly. Then plus c. Then let's now simplify. It will be 3x to the power 7 over 7 minus 2x cubic over 3 plus 7x squared over 2 plus x plus c. So you can write it now as 3 over 7 x to the power 7 minus 2 over 3 x cubic plus 7 over 2 x squared plus x plus c. Is it clear?
Yes.
Yes.
Yes, teacher.
Let's now do these examples here. Evaluate each integral by applying theorem 4.23 and formula 2 in table 4.21 approach. Number 11. Integration of 5x plus 2 over 3x to the power 5 dx. Integration of 5x plus 2 over 3x to the power 5 dx. The first step here, I will distribute the integral sign. So it's like 5x plus the integration of 2 over 3x to the power 5. Then, here we have a 5 as a constant, so let's put it now like 5 integration of sign plus 2 over 3, and then here I will write as x to the power negative 5. Then 5. What is the integration of x? It is x to the power 1. So x to the power 1 plus 1 over 1 plus 1 plus 2 over 3. Then here we have x. Now it is to the power -5. So I will say -5 plus 1 over -5 plus 1. Then I will add it to C. So here now I have a 5 over 2 x to the power 2 plus 2 over 3 times x to the power -4 over -4. So let's write it as here like this here. This is 1 over -6. So here let's rewrite it now. Now here I will do it. I will simplify it here now. I have 2 over 3 x to the power -4 over 4. So I will, since we have x to the power -4, I keep it as in the denominator x to the power 4. Then here we have 2 over 3 times 1 over 4. Let's now simplify it. So it will be now -1 over 6. So it is -1 over 6x to the power 4 plus c. Is it clear?
Yes, teacher.
Yes, teacher.
Let's do now number 12. In number 12 here, we have the integration of x to the power -12 minus 3x to the power 7 over 5 plus 1 over 9 dx. So I will distribute now the integral sign. Then here we have x to the power -12. So I will add 1 over 1. -12 plus 1 over -12 plus 1. Then minus 3x to the power 7 over 5 plus 1 over 7 over 5 plus 1 plus. Now 1 over 9, what will be its integration?
One over 9 over 1 plus 1.
No.
It will be 9th root of x.
No. What's the integration of 1 over 9? Yes, grade 11.
0.
1 over 9x.
1 over 9x, thank you. Here we have, it's like 1 over 9. Keep it outside. The integration of 1 dx. Integration of 1 is x, so it is 1 over 9x. If you have, instead of it here like, not 1 over 9, let's have it as 2 as an example. Integration of 2. You will tell me it is 2x. Integration of 4, 4x. Integration of 7 over 5. It is 7 over 5x. I will not write it as 0. It's not a derivation, it's an integration. In the integration, the integral of the integral function will be expand. As you see, it comes, maybe it comes like 2 functions only. After that, it comes like 3 or 4, or yeah, I mean like you maybe have you take 2 terms, it comes as 3 terms or 4 terms. So you'll expand the function. So here now it comes like 1 over 9 x plus c. Then now here we have an x to the power negative half plus 1. It's x to the power half over half minus 3. Now look at here. Here we have x to the power 5 plus 1. We can write it as 5 over 5. So it is x to the power 12 over 5 over 12 over 5 plus 1 over 9x plus c. Then here now 1 over half, I mean the reciprocal of it, so it is 2 square root of x minus now 3 over 12 over 5. It's like this, 3 over 12 over 5. That's mean it's like 3 divided by 12 over 5. That's mean 3. Let's change the divide to be as multiply, and the reciprocal of 12 over 5, which is 5 over 12. So it comes like 5 over 4 after simplifying. Then x to the power 12 over 5, that's mean I have to put the fifth root of x to the power 12 plus 1 over 9x plus c. Is it clear?
Yes, teacher. Yes, teacher.
Okay. Let's do now number 13. In number 13 here, we have the integration of x to the power negative 3 minus 3x to the power 1 over 4 plus 8x squared dx. So it is the integration of x to the power. Now here we have negative 3. So I will write as negative 3 plus 1 over negative 3 plus 1 minus 3x. Now 1 over 4. I will add 1 to the new exponents here plus 8x to the power 2 plus 1 over 2 plus 1 plus c. After I integrate these functions, I will add c. Then here now, x to the power negative 2, because negative 3 plus 1 is negative 2 over negative 2 plus 3 times. Now x to the power 1 over 4 plus 1, here I can write it as 4 over 4. So it is x to the power 5.
Teacher, it is minus 3, not plus 3.
Okay, thank you. Over 5 over 4 plus 8x cubic over 3 plus c. Then after that here we have, you can write it or can simplify it as negative 1 over 2x squared. Because here I have 1 over negative 2, I can write it as negative 1 over 2. And x to the power negative 2, I will write it, it's reciprocal with its opposite exponent. So x to the power negative 2, it comes like x squared. Then here, minus 3 over 5 over 4. Like that's mean, like I did here. 3 divide by 5 over 4. It's like 3 times the reciprocal, which is 4 over 5. So it's 12 over 5. Then x to the power 5 the fourth root plus 8 over 3 x cubic plus c. Is it clear?
Yes, teacher.
Yes.
Now, let's do number 14. The integration of 10 over y to the power 3 over 4 minus cubic root of y plus 4 over square root of y dy. Here now, I can write it as 10 y to the power negative 3 over 4 minus y to the third, the cubic root of y. It is y to the power what?
1 over 3.
1 over 3,
Negative
thank you.
1 over 3.
Plus 4 over y. Square root of y is 1 over half. 1 over 2, sorry. So if I write it up, it's like y
To the power negative half.
negative half. Then equal. Let's now find the integration here. 10 y. Here you have negative 3 over 4 plus 1 over negative 3 over 4 plus 1 minus y to the power third plus 1 over third plus 1 plus 4y to the power negative half plus 1 over negative half plus 1 plus c. Then let's now simplify it. Let's try now with the first term here. It is 10 to the power, 10y to the power negative 3 over 4 plus 4 over 4, it is 1 over 4. Over 1 over 4. And you can write it now as 10 over 1 over 4 is 40. As I told you before, 10 divide by 1 over 4, that's mean 10 multiplied by the reciprocal of it, which is 4, yeah, that's mean 40. Minus y to the power 1 over 3 plus 3 over 3, it is 4 over 3. Over 4 over 3. And I can, since it is 4 over 3, so I can write its reciprocal now as 3 over 4 plus 4y, negative half plus 1 is half over half. 4 divided by half, it's mean 4 multiplied by 2. So it is 8. Then let's simplify it again. It comes like 40 fourth root of y minus 3 over 4 cubic root of y to the power 4 plus 8 square root of y plus c. Is it clear?
Yes, teacher.
Do you have any question?
No, teacher, thank you.
You're welcome. Now here you have this question A and B. This will be your homework. I will post it in the discussion room for you, and I'm waiting your answers. Tomorrow we will continue, inshallah.